We have so far compared a smart contract to a trading bot. But there's one more important difference to a trading bot that you need to know. When the trading bot is running on your computer, it's basically running non-stop. At any point in time, you could take a look at what the software is doing, and you would get an answer like, right now it's sending out bitcoins. Right now it's requesting the Bitcoin price from Binance, etc. So at every point in time, the software is doing something. Even if that something is just a timeout sleeper function waiting for X amount of seconds. That's still doing something. But that's not the case for smart contracts. They are only ever running when you interact with them. Imagine the trading bot as a real-time game like Fortnite. Even if you don't move your mouse or press any buttons on your keyboard, the game obviously is still running. Other players are moving around, things are happening even without you. And you can imagine the smart contract more like Who Wants to Be a Millionaire? You'll get 4 answers presented, and only when you decide on an answer, the game proceeds. And you'll get your response if you were right or not immediately. And now, what does it mean to interact with a smart contract? Okay, listen carefully. It means sending a transaction to it. I know, your mind might be blown now. What? Just sending a transaction to it means interacting? So I only have to send some ether to this address and I just interacted with it? Kind of. It depends on the contract. If the contract supports that you send ether to it, then yes, you indeed only need to send ether to it. But a smart contract with only one functionality would be pretty boring, right? So that's why in Ethereum, when you send a transaction to a smart contract, you don't have to send ether. You can alternatively just send any arbitrary data instead. This data is then used to determine which functionality of the software to execute and what data should be used as input. It's possible to send invalid data. In this case, you might be trying to run a functionality that's not actually supported by the smart contract. Maybe you accidentally put a wrong address or you confused the functionality. But don't worry, in this case your transaction is simply reverted, meaning it's ignored and never put into any blocks. But what happens if the functionality exists? Well, now the code is executed inside the Ethereum virtual machine. And what happens during the execution? Well, anything that happens just in the memory doesn't really matter, because once the execution is finished, all memory data is deleted. So the only thing we care about is the state. And that's why you could think of Ethereum also as a distributed state machine. And a state machine is a theoretical construct in computer science to describe such mechanisms. It's easy to imagine as a game where you might have 3 states: game over, game paused, and game running, and whatever the player clicks moves the game into a new state. If you want, try to create a state machine diagram like this, but for Who Wants to Be a Millionaire? Now for Ethereum, every transaction will bring the network in a new state. New state refers to the whole Ethereum network state, basically all storage, who owns how much ETH, and all data stored in all smart contracts. Each transaction will work on the current state and move the network to a new state. Or rather, each block where transactions run sequentially, since that's what happens in a blockchain, right? We always get a new block which moves us to a new state. Even for Bitcoin, only that in Bitcoin the data stored is simply this address has this balance, and in Ethereum a smart contract could store any data at once. So let's go through an example of how you would interact with a smart contract next.